Okay, so number one. Numbers is a game where you bet $1 on any three-digit number, blah, blah, blah. If your number comes up, you get $600. Find the expected winnings. Okay. So, what does that mean? So, remember, so this is like expected value, expected winnings. How do we do these casino game calculation problems? Remember, the expected winnings is going to be probability times value plus probability times value. So let's just list out the different values and next to them the probabilities. So what are the different values? What can happen to your bank account financially if you play this game? There's basically two things that can happen. You win or you lose. If you lose, how much do you lose? Yeah, -1. Losing is negative, right? You lose $1. If you bet your dollar, you don't win, you lose $1. Now if you win 600, don't you? 600. And, okay, so there's the two different. You're either going to lose $1 or win 600. Now, what's the probability that you're going to lose $1? Yeah, how many numbers are there from 000 to 999? 1,000 even, right? Because if it went from 1 to 999, that'd be 999. They're throwing in 0 on top of it. That gives them 1,000 numbers, right? So there's 1,000 numbers there. They're only going to pick one number, so your chance of winning... Oh, whoops. The chance of winning is 1 in 1,000. Your chance of losing is 999 in 1,000. Good? So, and then what do? You just multiply those, don't you? You just multiply, and then add them up. So -1 times 999 over 1,000 plus 600 times 1 over 1,000. Now, do you know you can just make that minus 999 plus 600, because they already have a common denominator, don't they? So it's minus, 399 over 1,000. And I can divide by 1,000 without a calculator. Just move the decimal back 3 places. 1, 2, 3. Minus 0.399. Is that not there?
No, that's not there.
That's disturbing, huh? So it's basically minus 40 cents. Right? So you're expecting... What does that mean? What does that mean? That means on average you're going to lose 40 cents every time you play the game, which is weird. You can't lose 40 cents. You're either going to lose $1 or you're going to win 600. But they mean the average is it's like you're losing 40 cents every time you play, because you're going to usually lose every now and then win. If you played that thousands and thousands of times over decades of your life, in the end, the average would come out super close to handing the casino 40 cents every time you played the game. That's going to be the average. That's the calculations they do and insurance companies do to know what they can expect to happen with their randomness. Funny how randomness ends up not being so random in the long run. Okay, number 2. Is that good there? Questions on that? So it's just value times probability. Value times probability. So that's none of the above. E. And that is the answer on number 1? Somebody's already done that? Good, okay. Number 2. Suppose a charitable organization decides to raise money by raffling a trip worth $500. If 3,000 tickets are sold at $1 each, find the expected value winning for a person who buys one ticket. All right, oops, I did the wrong one. What's it still doing it? Let's try that one. So, can you do that one? You try. So it's just value probability, just multiply, huh? So just make a table like I just did. Just list out the various money values and then put next to them the probabilities. Just multiply those and add them up. Let me give you a second. How are we doing? So what can happen? You can either lose $1 or win 500, right? And what's the chance you're going to lose $1? There's 3,000 tickets. So 2,999 out of 3,000. Chance you're going to win $500 is 1 in 3,000. Multiply, add them up. So negative 299 plus 500 over 3,000. That good? Am I going too quick? Because this ends up being negative 299 over 3,000, right? When you multiply the negative 1 times this fraction, it goes to the top, right? Because it's a whole number. Like the 500 is over 1, and the negative 1 is over 1. So it goes to the top, and this one ends up being 500 over 3,000. Is that good? Then you just add them up. You just multiply. So that's all you got to do to figure out average value or expected value. So for anything random, it's actually not so random. There's an average in the long run. You just multiply the money times the probability, and add them up. So if you add those up, what do you get? Is that minus, I don't know, 500 minus 299. It's minus 2499 over 3,000. I'm getting minus 0.833. Did y'all get that? And is that there? Oh, yeah. So, yeah, and that's close enough, by the way. You'd round to the nearest penny, huh? So don't choose none of the above there. I'm not trying to fool you. I'm really not. Just minus 83 cents, so you plan to lose 83 cents. Every time, on average, every person that does that will lose 83 cents on average. Good? Easy enough for number 3. How many different four-letter radio station call letters can be made if repeats are allowed and the first letter must be K? So let me give you a second. Remember what I suggested on these kind is to actually do the thing? Like pick one. Pick a four-letter. It's WKRP or something like that. So, WKRP. So I just picked one. So remember, just actually doing it helps. So how many decisions did I make? I made 4 decisions. And how many options did I have for each of those decisions? How many options for the first decision? Oh, the first letter must be K.
Yeah.
Thank you. Thank you. KKRP. All right, because repeats are allowed, right? And so, yeah, good, thank you. So how many, for my first decision in which I chose K eventually, how many options did I have? 1. I thought I had more options. But in reality, I only had 1 option, K, huh? For my next decision, how many options? 26. Remember, there's 26 letters in the alphabet. You put that on your full sheet of notes if you're not sure you're going to remember it. Next 26, next 26. Huh? It's 26 times 26 times 26. Is that what it is? 17,576. Yep. There it is. Good. Decisions, options. Number 4. In how many ways can 2 letters be chosen from the set A, B, C, D, E, F if order is important and repeats are allowed? Give you a second there. Try that one. You could do the same kind of thing, though. What's it called? The decisions options. You could do the decisions options, or you can do like a P or a C thing. It'll work either way on this one. I don't know if you remember the P and C stuff. Either one will work.
Oh, super easy. I was like, wow.
You're happy about that, huh?
Yeah, I was like, whoa, okay.
That's easier than it should have been, huh? All right, let's see. Okay, so, yeah, you could say, look, I'm going to do one, 2 letters. All right, B, E. There we go. I chose 2 letters from the set. All right. How many decisions? I actually did it. How many decisions did I make? 2 decisions. How many options for the first decision? How many when I chose B, how many options did I have?
6.
There were 6 different letters that I could have chosen from, huh? When I made my second decision, also 6, 36. Boom. Now the other way is you can just do the P thing.
I got D.
It says repeats. are allowed.
Repeats.
Yeah, but it was 30. I got D for that one.
There's no repeats are allowed.
It was the NC.
So it'd be 6.
Oh, is there a no off the screen? Yeah, I was trying, but somebody had to pipe up because she's done the work. Good job, thanks.
I was due. Like, I was like, oh.
Yeah, no repeat. Oops, I just hit the little button. No repeats are allowed. So that means that you could choose like B and then E. You'd have 6 options and then 5 options, 30. Because whatever you chose the first time, right, when I chose that E the second time, I couldn't choose B again. I had 5 options. I had one less option because I could not use whatever I used the first time, huh? 6 options for the first decision, 5 options for the second decision, right? 30 options. Thank you, D. Or the other way is you could do P or C. Which one is it? Is it a P or is it a C? How do you know? What's the difference in those?
Yeah.
Yeah, remember I said when you order a combo pizza, some of my old office mate years ago, he's down in San Diego now. I don't know why he got a job in San Diego and I'm in Fresno. No, I could not afford to live. He has no kids, so he can afford to live in San Diego. I couldn't pay for 5. Yeah, I could get rid of the kids. My wife and I would have fun in San Diego. All right, combo pizza. So he used to say, that was always his saying, Richard Fielding. He'd always say, combo pizza. He said, you never say the order. You never tell them what order. So there's no order on combo pizza. So the C has no order. P has order. So what did they say? Did they say order matters or doesn't?
It says order is important.
Order is important. This is P. So it's out of 6, pick. Out of 6 letters, pick how many? 2. Out of 6, pick 2. So if you do the 6P2 on your calculator, you get the same answer.
Just made it easy.
30. What's that?
Made it easier.
Yeah, either way. So out of 6, pick 2, or 6 options times 5 options. Either way, you get 30. 30 different ways to do it. Am I making sense? That means if you listed them all out, if you said, okay, you could pick A and then B, or A and then C, or A and then D, or A and then E, or A and then F, or you could pick B, blah, 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 blah. You'd find 30 different total options of 2 letters, which I don't want to list them all out. We'll just take their word for it. All right. Onward we go. Unless you have questions, that makes sense. It was 6P2, which comes out to be 30. Number 5, libraries to be given 7 books as a gift. The books will be selected from a list of 23 titles. If each book selected must have a different title, how many possible selections are there? Do you get the feel? There's 23 books, you're picking 7. Right? Out of 23 titles, grab 7 for the library. That's basically what they're saying in so many words. So you're looking at 23 things, and you're going to pick 7 of them. So all you got to decide, is it a P or C? Give that some thought for a second. Try to be real with it. Try to be as real as you can. Does the order matter? If you're the librarian, just make it real. Imagine a little video. Make a movie in your mind of you doing this. And say, okay, I'm the librarian. Somebody hands me the list of 23 books and says, hey, would you pick 7? Would it matter which order you pick them in? No. You just feel it. Nobody cares what order. Just which 7 you picked, huh? So is it P or C? C. Out of 23, choose 7. Making the 23 big. Out of 23, choose 7. So hit the buttons on the key. You guys know how to do that in a calculator, right? 23, hit the math, go over to probability, down to C. 7. I'm getting a big number. 2, 4, 5, 1, 5, 7. Wait, is that what I got? 23, choose 7. So it doesn't look like C to me. Oh, it's A. Okay? Good? All is well? So see why that's C and not P? Let's try number 6. For a motorcycle traveling at speed V in miles per hour, when the brakes are applied, the distance D in feet required to stop the motorcycle may be approximated by the formula, blah, 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 blah. So if you hit the brakes on your motorcycle, That's how far you're going to go. Find the instantaneous rate of change of distance with respect to velocity when the speed is 45 miles an hour. Woo! When did we get in physics class?
That's the calculator.
Yeah. Do you recognize that?
Yeah.
What? There's one word there.
Instantaneous.
There it is. Instantaneous. That's the word that needs to jump off the page. And rate of change. Remember what that was? That's section 11.3. That was our last section we were working on. Remember? Instantaneous rate of change. If you see that, versus, and we also did average rate of change. Remember those two? So if you see instantaneous, let me go to a fresh. So when you see instantaneous rate of change, you think, oh, I've got to do that rule like you take the power on each letter, comes down to the front and multiplies, then lower the power by 1. That's the first rule. Any numbers with no letter next to them vanish. Poof. Gone. That's what I forgot to tell you, by the way.
Yeah.
Yesterday, the last homework problem had a number that had no letter. I think it had 100 or something.
It was.
Sorry about that. We just ran out of time. It had like 100 minus x squared or something, didn't it? Wasn't that your formula they gave you? And when you do the derivative, so what I'm saying is the 2 has to come down to the front, and the power goes down by 1. Lower the power by 1. What happens to the 100? Bye-bye. He vanishes. Because he doesn't have it. Now, if he had 100x, that'd be a different story. If he had an x next to him, or x to the third, or x to the fourth, or whatever. But if you just have a number like 100 or whatever number with no x next to it, bye-bye. It just goes away. That's called the derivative from k. Doing a little bit of calculus here. So anyway, that's how you did that last problem, but that's not our formula. What's our formula? And then number 3, at the end, plug in. Plug in. So that's the last thing you do. So, okay, grab your formula. Here we go. It's 0.05 v squared plus v. You ready? We're going to do the little calculus thing. The power on each letter comes down to the front and multiplies, and then you lower the power by 1. You ready? There's 2 separate terms. We're doing calculus. All right. What's the power on this guy? This is the first term. This is the second. We'll do them one at a time. By the way, what's the power on that second v? I don't see any power. Invisible 1 is really there. Huh? It's not 0. It's invisible. It's v to the first power. It's 1v. Anyway, here we go. What do I do with this 2? Bring it down. It's going to multiply, and then you lower it to 1, huh? And that is what? 0.10 v to the first? When you multiply 2 times 0.05, 2 nickels is 10 cents. Plus, and then what happens to the other one? Same thing. Am I going too quick? You tracking with me? So you take the power, you multiply it to the front. 2 times 5 cents is 10 cents. Then you lower the power by 1. And then what do you do for the second one? Same thing. You bring the power, comes down to the front, and then lower it by 1. What is 1 minus 1? What does it become? 0. But see, I brought it down and lowered it by 1. That's what we always do. You take the power down to the front, lower it by 1. And what is anything? Now, this is something you need to remember from your algebra days. Not a calculus rule. It's an old algebra rule. What's anything to the 0 power? 1. Do you remember that? That just becomes 1. Anything to the 0 power is 1. So then that's 0.10v, it's a v there, plus 1. And at the end you plug in. Plug in what? Whatever they give you. Did they give me a v? V, velocity. Speed, velocity, same thing. 40, I can't read that, so 45? Yeah, 45. So just grab that 45 and plug it in for v. So 0.10 times 45 plus 1, that's 4.5 plus 1, 5.5. There it is. 5.5. That making sense on that? A lot of the battle on a math final or a science final is recognition, huh? There's so much stuff. So how are you going to recognize this question on the final with everything else? What's the key word? Instantaneous rate of change. Did everybody see that? That's the key phrase. That won't be said on any other problem. Instantaneous rate of change. You do this. So put this on your full sheet of notes. Best way to make your full sheet of notes is right now, as we're doing the practice final. And when you finish it up this weekend, ignoring your mom and Mother's Day, and do the practice. I'm just kidding again. Do the practice final. As you do it, make your full sheet of notes. Every time you need something, like right now, hey, you think, oh, I need these steps. Okay, write them right on your full sheet of notes. Questions I can answer on that one? What if there had been another term out here like a plus 82? That would just disappear because it doesn't have a V. If it doesn't have any letter next to it, it just vanishes, right? But for all the letter ones, you bring the numbers down to the front and lower them by 1. And then plug in at the end and get your answer. See, calculus is not too bad, huh? Just the beginning of it there. Just a little bit of calculus. The new ones here. Okay, so this is number 7. So the graph, blah, 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 blah. There's one keyword that needs to jump off, or 2 keywords. What is it? Average. Whoops, I just hit the button there. Average rate of change. You see it there? Average rate of change. So when you see average rate of change, you go, oh, that's one of that last section we did. That's that 11.3 thing again. And they want average rate of change. What is that's different than instantaneous. Everybody see the difference, right? Let me help with that. Suppose I drive my car from Fresno to LA. What's that, like 250 miles, let's say? 250 miles, okay? And let's say I do it in 5 hours. I drive from here to LA, 250 miles, and I do it in 5 hours. What was my average speed? Yeah, because I went 250 miles in 5 hours. Divide that. That's 50 mph, huh? If I covered 250 miles in 5 hours, I average 50 miles an hour. That's slow. That's my average speed. Now, really, that doesn't mean I went 50 the whole time, huh? I didn't come out of my driveway at 50 miles an hour. My neighbors would be concerned, right? So I came out slow, eventually got to the freeway, probably did 60 on the freeway, or probably should do 65, 70 most of the way, but maybe I stopped for a half an hour to look at the sights or something. Potty break halfway through the trip for half an hour, and then got back in the car and finished. So maybe I really went 70 most of the way, but took a half an hour break in the middle or something like that, right? And slowed down in the beginning, slowed down at the end. So anyway, that's just my average. That's different than instantaneous. If somebody said, how fast were you going at exactly 1 hour into the trip? Or exactly the last 5 minutes? Probably not 50 miles an hour. The last 5 minutes, I was probably slowing down to where I was going to arrive. So, right, you get the idea between the difference between average and speed is a rate. It's a rate, like a rate of change. It's how fast your position is changing. So you see the difference between instantaneous and average. There's a difference, isn't there? So when they ask me on this question, what's the instantaneous? That's harder. Like, if I told you I went from here to LA in 5 hours, 250 miles, 5 hours, you don't know anything about my instantaneous, do you? You don't know anything. All you know is my average was 50. Instantaneous is a much more difficult question. You need much more data. That's why it takes calculus. So with calculus, you can get how fast that motorcycle is going at an instant in time. Much more specific information. That's what all this is, that derivative stuff where you bring down the power and blah, blah, blah. While that is true and how it all works and applies, that's calculus. If you want to learn that more, you take calculus. Calculus is a very powerful, powerful subject which is used in many, many fields because it can do things like that. It can find how fast you're going at an instant in time, much more useful than just the average. So, but anyway, I want to help you for the test we take next Thursday, the final, to be able to distinguish the difference. Instantaneous, you should think, that's hard, that's calculus. That's the bring the power down, lower it by 1. This one, average rate of change, that's no big deal. Average, how do we do average? Well, remember what we do for average? We do what? Slope, exactly. That's slope. Remember, a slope is an average. It's y2 minus y1 over x2 minus x1. And they're saying from where to where? We'll see how here they say 10 to 40. That's your x1 and your x2. They're saying from 10 to 40. In other words, what is this? This is sales for this company. The graph shows the total sales in thousands of dollars from this company, from distributing catalogs. So they pass out the catalogs, they get more sales. This would be a marketing company, and they're wondering, hey, how effective is it when we pass out these catalogs? Today, not at all, because we have the internet, right? Nobody cares about physical catalogs. But maybe back in the day, this would have been a good way to advertise and to get your product out there. So to see how the x-axis is number of catalogs they distributed, and the y-axis is sales. So they're saying when we distributed only 10,000 catalogs, right here we had $40,000 in sales. When we distributed 40,000 catalogs, we went up to $60,000 in sales. You see. See what we're finding with those two dots? And so they're wondering, what's the average change, the average rate of change in sales per catalog? So we just say, okay, this is x1, y1, x2, y2, isn't it? So y2, 60, minus y1, 40, over x2, 40, minus x1, 10. And that's 20 over 30, 2/3. Boom. Does that make sense? What is that in real life? What does that 2/3 mean to a marketing person? Remember, it's rise over run. What is rise? Sales. It's sales over catalogs. So the run is catalogs. In other words, $2 more in sales for every 3 catalogs you pass out. Now, between those 2 points, between here and here, every time they went up by 3 catalogs, they increased their sales by $2. It's the rate, it's how fast sales went up as they passed out more catalogs. 3 more catalogs, $2 more sales. 3 more catalogs, $2 more in sales. That's the rate of change. That's the slope of the line connecting those 2 dots, is what that really is. Does that make sense? It's rise over run for that line. It's the slope of that line on the graph. In calculus, you talk about that line, and then you talk about the line that happens right at the point. So right here, the slope it looks steeper, doesn't it? It looks like that's called the tangent line. Anyway, this isn't calculus, so we'll just stop there. So there we go. We're just finding the slope of that line connecting those 2 dots. Average rate change. All right, so 2 kinds of questions. You see instantaneous, you do the calculus thing where you bring down the power. You see average rate of change, you do slope. So you want to have that on your full sheet of notes for the final exam for Thursday. All right, we're done. Those are the new questions. Let's go to the old ones. So starting at number 8, I'll do 8 because it's not. Okay. 2 snakes on 13 acres and 18 snakes on 28 acres. Let y be the number of snakes. Write an equation for the number of snakes. Y number of snakes and x acres. Write an equation. Okay, so basically we want this relationship between how many acres, how many snakes. So basically, do you realize they're letting y be snakes, x be acres. So this is x, this is y. Call it x1, y1 if you want. This is x2, this is y2. They're basically giving me 2 points, aren't they? Do you see that? They're giving me 17 acres, 2 snakes. 28 acres, 18 snakes. Acres, snakes. Because they told me to let X be acres and Y be snakes. Acres and snakes, acres and snakes. Okay. So, take those 2 points and find the equation of a line. Do you remember how to do that? Maybe not so much. It's been a long time. It's been like 15 weeks. Yeah, start with the slope. First thing you got to get is the slope. Slope is same formula as you know, y2 minus y1 over x2 minus x1. So this again, this is x1, y1, x2, y2. So y2, 18 minus y1 over x2, 28 minus 17. 16 over 11, is that right? Yeah. So there's the slope. Now, what do we do from there with that slope? Yeah, you write the slope formula one more time, and this time with the blanks. Is this the way I showed it? There's other ways. If you know there's lots of those. You use y equals mx plus b. You can use y minus y1 equals m times x minus x1. It's called the point slope formula. That's fine. I found this is easiest for students over the years. Students showed it to me many moons ago, and I thought, yeah, that's nice. They'd heard it from some other teacher, and I thought, yeah, that's easy. That is easier. So I'll just show you this way. So it's not how Math Excel shows it. All right. So what do we? So I'm using the slope formula again. This time with blanks in the back. Does everybody see that? I use the slope formula once here where I put in all 4 numbers. And then I use it again, and I'm just going to put 2 numbers in the back. Which 2? Either these 2 or those 2. It matters not. Either one will work fine. But only 2 will go in the back, and the slope will go right there. So 16 over 11 will go right there. And in the back, we'll go, I'll just do 17 in the back of x. Careful, that's the x goes in the back of x. And 2 in the back of y, and then I'll cross multiply. See what I did there? So it's like you're using the slope formula twice. That's also why it has proven to be easier for my students over the years, because it's like the same formula. It's not really like a new formula. It's like the same formula twice. The second time, it's just got blanks in the back with a plain y and plain x. You just plug in 2 numbers instead of all 4. All right, and then we cross multiply. Diagonal, diagonal. 16 times x minus 17 is 11 times y minus 2. Good so far? Distribute. Distribute. 16x minus 16 times 17 is what? 272 equals 11y minus 22. We're getting close. Now, notice how all the formulas over here have 11, except for D. D's clearly not right, or probably not right. All those have 11y, huh? So let me get 11y alone so I can see which one of those is right. How do I get 11y alone? Got to get rid of that 20. Doesn't matter right side, left side. That doesn't matter at all. Just add the 22. So 11y is 16x minus, is that 250? Minus 250? So it's none of the above? Oh, that's so disturbing, huh? And it's close. They have that plus 250 there. It's just tempting. But you have great confidence in your math skills, and you know you're right? So it's none of the above. There we go. Is that okay on that? How to find the equation of a line? So we use the slope formula twice, once with all 4 numbers. Once we have that, we start again with just the 2 numbers in the back and the y and the x in the front. Cross multiply. All right. So what else do you want to see?
I had a question. So you put the parakeet, dog, and cat back up on the practice exam. And then I remember you wanting to take it out because it was difficult to solve.
Oh, really?
Yeah.
But the final, they're all mixed up. Yeah. So let's try that one. Number 9. A new car was purchased for $14,400, and 3 years later it was worth $8,700. Assume that the depreciation in value is given by a linear equation. Find the value of the car at the end of 4 years. So it's another one of these linear equation ones. go. See if you can find it. It's the same kind of thing. You want to find, you want to have y equals mx plus b kind of thing. You got to find the slope in the b. Yeah, this one's a little tricky. Y equals mx plus b. The x is going to be the years old, and the y is going to be the value in money of the car. Does that make sense, first off? X is going to be the years old, and y will be the value. How do I know to write y equals mx plus b? Linear equation. Right there. Linear. That's linear, meaning the graph is a line. Linear equation means the graph, meaning x and y are first power. Anytime you have x and y first power, if you had x squared, that means a U shape, huh? It's not a line anymore, and other stuff. So as long as x and y are both just the first power, that's what we call a linear equation. I mean, the graph will just be a straight line; it won't have curves. So that's the general linear equation. Y equals mx plus b. When you read linear equation, write that. Okay. Let y be the year. X is how many years old the car is. Y is the value. All right. So let's take it piece by piece right here. 14,400 new. What does that mean? Yeah, new means 0 years old. So they're saying when x is 0, y, the value, right? So that means at 0 years old, the value was 14,400. The y was 14,400 when the car was 0 years old. So do you see that 14,400, then this just goes away as just b? You see how that just tells you b? Because m times 0, the m times 0 drops out, and it's just b equals 14,400. That's the y-intercept, we call it in algebra. You see what I did there? I just plugged in the information they told me the first time. I'm going to get to the second fact in a minute. The second fact will say 3 years old, 8,700 value. I'll get to that in a minute. These are basically xy points again, aren't they? They're giving me. Do you see? So again, the first one, 0 years old, brand new, 14,400. So 0 for x, y is 14,400. So that tells us b. So now we know b. We know what b is. So let's go back to our equation. We'll come on down here. Our y equals mx plus b. But what is b now? 14,400. I put that in the place of b because that says right here, that's what b is. So now, I just need to plug in the second bit. Oops, I hit the button there. The second bit of information. X is 3 years old when y is 8,700. See what happened there? I'm probably confusing you, huh?
Yeah,
All right, how about this? Let me back up. I could do it a different way. I mean, what I'm saying is true, but it's not good of me to change methods on you. Let's go back. Yeah, just do it like the last one. Yeah, this is 0, 14,400, 3, 8,700. Right? Because that's x, x1, y1, x2, y2. Just like the last one. How about that? Just let the years old in the value, years old in value be x, y, x, y. That's x1, y1, x2, y2. So far, so good. So what's the slope? y2 minus y1, just like we did last time, right? Over x2 minus x1. How we doing? Good. So y2, 8,700 minus y1, 14,400 over x2, 3, minus 0. If you work that out, what's your calculator tell you? I'm getting negative 5,700 over 3 equals negative 1,900. Good? Everybody see what I did there? So basically I just took x1, y1, x2, y2, years old value, calculated slope, y2 minus y1 over x2 minus x1, got minus 1,900. So that's my slope, okay? My equation, remember, is y equals mx plus b. Where's the slope go? Slope's the m, right? We good there? So the m minus 1,900. So that's the m minus 1,900. What's the b? That's the b, because the b is what you get when x is 0. B is the initial value of the car. Am I losing you on these? Remember these? Remember, y'all did pretty well in exam 1. You knew it back then. It'll come back. It'll come back even stronger the second time. But you do need to review. You do need to go back over those old YouTubes and work out these problems. So it's minus 1,900x plus b. B is 14,400. That's the b. Everybody see that? The b is always the amount when x is 0. Why? Because see, if I put in x equals 0, see how y would equal 14,400? You see that? When x here is 0, y is 14,400. So if you make that b 14,400, that'll be the value when x is 0. So, okay, so what? Now we're ready to answer the question. What is their question after all this? Find the value of the car after 4 years. How do you find the, now that we have this formula, how do we find the value of the car after 4 years? X is 4. X equals 4 years old. Remember, because X is years old. So plug in 4. So there we go. Hit the buttons on your calculator. I'm getting 6,800.
Yep.
So we're $6,800. It's not there? That's rough.
Always the hardest one.
It's always the hardest ones are none above, yeah. Hey, look at that question for a second with reasonable eyes and tell me which two answers are ridiculous. C and D. Do you see why C and D are ridiculous? The car's going down in value. Cars do that. Right? It was 3 years later, it was worth $8,700. It had gone down from $14,000 to $8,700. How much at 4 years? It's going to go down even further. It's got to be below $8,700. It can't be $12,000 or $18,000. Those are ridiculous answers, huh? Anyway, just to help yourself out if you need to guess or, you know, sometimes eliminating some things can help. Being reasonable. Anyway, other questions I can answer on that one? Good? All right. How are we doing? What else? Okay, so it says write it, you know, which one of those is right? So remember how the log properties work, how you combine several logs into one? Remember adding is multiplying, subtracting is dividing? Remember all that kind of stuff? So we'll say, okay, this is added, this one's subtracted. So make it a single. Oh, and these two, like the 2 goes up to the power, the 7 goes up to the power. So it's going to be w squared times z to the 7, because that's adding, over x minus 5, because that one was subtracted. Oh, is it just A? There it is. Everybody good on that one? Remember those properties? Adding becomes multiplying. Right? So if you have, remember the property, the first property said log of x plus log of y is log of x times y. Remember that? Adding two logs becomes multiply. Subtracting two logs is divide. Remember that? And the third property said that if you have a power, it can come down to the front. Or vice versa. You can run those properties both ways, right? If you have a power, you can bring it down to the front, or you can put it back up to the power, depending on what you're trying to do. So I took this number in the front and put it back onto the power, because they wanted me to crunch them all together into one log. Is that good on that one? Number 14. Write the expression as a sum and or difference of logs with all variables to the first degree. Yeah, that's kind of tricky. Let's do that. So take this one. Come on down here and separate these. So ln of the square root, is that an f? Yeah, f z over z cubed. Oh, yeah, it's a little bit of a hard one. Really hard one. Okay. What's the square root as far as a power? Do you remember that? Square root's a half power. So that's an important fact to remember. If you have the square root of anything, blah, 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 it's blah, blah, blah to the half power. I'm not seeing any recognizing looks on your faces. Does that look like it's brand new fact you've never seen before? Look back to the YouTubes. We talked about that back in January or February or something. So anything with a root on it is a half power. It's another way of writing a root. So what? Well, then that means this is ln of fz to the half over z to the third. You with me so far?
When division and subtraction.
And now we're going to break them into subtraction. So we'll go ln of... And the powers can come to the front, huh? So it's a half ln of fz minus 3 ln z. We good so far? See what happened there? I put the powers down to the front, and I made it subtraction because it was divide.
I totally zoned out.
Is that good?
No, I totally zoned out on you right now. I was like,
That's okay. So making sense. So I took that. So root is a half power comes to the front, third power comes to the front, and dividing means subtraction. Everybody seeing that? So now we're almost there. Now the real trick at this point you want to grab D, huh? You know what D is? It's a lure. They're baiting you. You bite D, you're in the net. It's not D. There's one more step of simplification. This is a rough problem. Because this has a Z and this has a Z, we somehow have to put them together. D is really right, it's just not done. It's not finished. Well, what do? Well, remember what multiplication? That's F times Z. What's multiplication? Adding. So make this a half ln F plus a half. They both get the half. Good, so it's just getting scribbly there. Yeah, it's always run out of room on these. These are long. Yeah, there's so much we've done. We did a lot of math in this class. So half ln F plus a half ln Z, and then the other part is still there also. We good so far? Do you see that, right? The FZ becomes added. Two separate logs added. That's what that first property says. One log multiplied, two logs added, huh? That works for ln or regular log, any log. Okay, so what? Well, now I have this guy and this guy like terms. What's a half a pi take away 3 pies? What if you have a half $1 and then you lose $3? What if your bank account goes up $0.50 and then down $3? What's the net effect to your bank account? No idea? So what this is saying? Gain of 1/2 of an LNZ and a loss of 3 LNZs. How do you put those together? If your bank account goes up $0.50, stock market goes up $0.50 and then drops $3, right? Plus 1/2, -3, LNZ, -2.5, right? You with me? You go up 50 cents and down 3, you're down 2.50. So that means this is 1/2 LNF, that part's just sitting there, no change, minus 2.5 LNZ, right? Because plus 1/2 minus 3 of the LNZs. And what's 2.5? 5/2. If you multiply and add the top, remember how you convert, mix numbers to improper fractions? You multiply and add the top. 2 times 2 is 4. Add 1, 5/2. That's minus 5/2. There it is. That's hard, huh?
Yeah.
A lot of little rules there on that. Is that good? How are we doing? Questions I can answer on that one?
What are the ones that have like 3 different equations?
Linda invests $25,000 for 1 year. Part is 5%, part 6, part is 8. So that would mean 0.05x plus 0.06y plus 0.08z is, that's actually the investment. The total income is $1,600. That would be the $1,600. And then the x plus y plus z would be the total investment, $25,000. Sorry, I know I'm going quick. That's what those two facts mean. So you put the interest rates with what she earns, $1,600. The total investment is $25,000. And then it says the amount at 5%, that's x, is double the 6%, 2y. That's the third equation. See how that's 3 equations, 3 letters? Okay. So now, what do you got to do? Let me bring it down. We got to take this one, and we got to get him lined up like the others. See how you want x's, y's, and z's on the left, numbers on the right. So jump him over, and you'll get x minus 2y, and then plus 0z, really. And then you put it in a matrix. Remember how we learned to solve with matrix? It'll be 0.05, 0.06, 0.08, 1600. And it'll be 1, 1, 1, 25,000. And it'll be 1, -2, 0, 0. Put that in your calculator, do the RREF. And you'll get your answers out of that. We are going to have to stop there. So you could type that in and get your answers. I'm sure it's on those old YouTubes for you to see, for your solving enjoyment.